Task 5. How many infractions are required to be marked as naughty on Santa's naughty and nice list? What are the names of at least 6 insider threat moles? Who is throwing the snowballs from the top of the North Pole Mountain, and what is your proof? A couple of the files from the file store compromised in Task 5 are of use in this part of the challenge. One concerns a North Pole Police Department report of a disturbance. This gives away the web address of the police department, which in turn contains a database of children's infractions. Separately, another file contains an export of each child and whether they have been determined as being naughty or nice. So, calculating the number of infractions required to be marked as naughty is just a case of cross-referencing these two datasets. The query interface makes it easy to extract the complete infractions dataset, although it's necessary to do this in 3 steps, one for each status. The data returned is in JSON format, although this is easily converted to CSV using json-csv.com. These are recombined into one table in Excel, a pivot table created to calculate the number of infractions per child, and a VLOOKUP to compare against the naughty and nice list. A child is considered naughty for 4 or more infractions. The police report found in the file store was about 2 Munchkin moles impersonating elves in Santa's workshop. When confronted, they pulled people's hair and threw rocks. The infractions data includes cases of pulling hair and throwing rocks, so it may be a safe assumption that the 6 moles that we're tasked at finding will be those who have both pulled hair and thrown rocks. They can be identified by a new pivot table with names on each row, infractions on each column, and number of infractions as the data. Tweaking the pivot table filters will show only people who have thrown rocks in some way or have pulled hair, so a small formula is required to search for cases where someone has pulled hair and has thrown rocks, either at people or otherwise. This returns 6 names of likely moles. The final part of this question is to find out who's been throwing snowballs from the top of North Pole Mountain. Now, I'm guessing that some completion of the snowball puzzles unlocked this NPC conversation where we find out that the abominable snow monster is the culprit, but that he appears to be hypnotized. Someone else is the real villain, so our quest must continue. Task 5 complete. Task 6. The North Pole engineering team have introduced an ELF-as-a-service platform to optimize resource allocation for mission-critical Christmas engineering projects at eaas.northpolechristmastown.com. Visit the system and retrieve instructions for accessing the Gradebook page from C drive gradebook.txt. Then retrieve the Gradebook PDF file by following those directions. What is the title of the Gradebook page? Sugar Plum Mary offers a number of hints to help achieve this objective, including a link to an article which offers a more detailed description of XML External Entity vulnerabilities and how to exploit them. It essentially boils down to improper processing of input data by an XML parser. The ELF-as-a-service application allows the user to upload an XML file, so this looks like the attack vector to go after. In order to pull off this attack, a malicious DTD file needs hosting in a location where the target server is able to retrieve it. I spun up an Nginx web server in a Docker container for this purpose and configured the DTD payload to exfiltrate our target file C drive gradebook.txt to the same server. As the context of this file will be included as part of the GET request string, no special mechanism is required to receive it. It'll just be visible in the logs. The malicious XML file is prepared, pointing towards the hosted DTT file, and uploaded to the ELF-as-a-service app. The web server logs show the target server downloading the malicious DTD file, followed shortly by another request which contains the contents of the gradebook.txt file, which is a URL where the page itself can be downloaded. Task 6 complete. Task 7. Like any other complex SCADA system, the North Pole uses ELF machine interfaces to monitor and control critical infrastructure assets. These systems serve many uses, including email access and web browsing. Gain access to the EMI server through the use of a phishing attack with your access to the EWA server. Retrieve the Gradebook page from C Drive Gradebook page 7. What does the Gradebook page describe? Shiny Upper Tree provides a crucial piece of information for this task. Alabaster Snowball checks his emails from the EMI system that we're tasked with attacking. Furthermore, some of his emails discovered in task number 4, the webmail challenge, suggests he's desperate for Mrs. Claus's gingerbread cookie recipe. So desperate, in fact, he'll click on through any security warnings to get to it. Another email from Minty Candy Cane is raising a concern about a Microsoft Word DDE exploit, which can be used to execute commands. The email helpfully includes a link to a blog post which explains exactly how to accomplish it. Finally, a last set of emails tells us that Alabaster is a big lover of Netcat, so hopefully it'll be installed on the EMI server for us to fire up a reverse shell, just like in task number 2. Before we can do that though, a listener needs to be started first, then a malicious Word document formulated, and finally email to Alabaster via the webmail system. Shortly after it's sent, Alabaster opens the email and the reverse shell connects. This task requires obtaining the Gradebook page stored in the root of the C drive. I chose to use a second Netcat connection to exfiltrate this file, so another listener is required, this time redirecting its output to a file. Then launch a second Netcat on the EMI server using the Gradebook page as its input. Gradebook page obtained, task 7 complete. Task 8. Fetch the letter to Santa from the North Pole ELF database at edb.northpolechristmasdown.com. Who wrote the letter? In this last challenge, OneOrs provides a few pointers as to the several steps required to achieve the objective. Firstly, he mentions cross-site scripting, then JWT tokens, then LDAP injection. The ELF database site sits within the private North Pole network, so we need to start by reconfiguring our tunnel again and adding appropriate host file entry. The EDP page consists of a logon page and a help form for password resets. Given OneOrs's hints, it is probably this reset form which is vulnerable to cross-site scripting. If so, we could run malicious JavaScript within an administrator session. The article OneOrs points to provides numerous methods to try to evade cross-site scripting filters. However, one which is not properly filtered is the SVG tag. The alert function provides confirmation that this is not filtered and can be exploited. With a way to trigger JavaScript execution, the next job is to define a payload, ideally something which will grab some session data and send it back to somewhere the attacker controls. I reused the web server I set up as part of task 6 and formulated an AJAX call to send back any cookie data. This returned a session cookie, but attempting to use it was not fruitful. So I started digging a little deeper in the code and noticed that the authentication process relied on the presence of some data in the npauth local storage item. Updating the JavaScript payload in the cross-site scripting attack and resubmitting it provided a much longer data item. OneOrs's hints for this part of the challenge make reference to JWT tokens, and sure enough, feeding the captured data into a JWT decoder shows this is probably being used to store the session details for the current logged on user. This exact token isn't directly usable to steal Alabaster session, as it is already expired. Adjusting the expiry is easy, but the modified token won't be trusted unless it is signed using a particular secret key. This decoder uses the key secret by default, and the big red invalid signature message indicates that this is not the correct key used to sign this token. OneOrs's hint specifically highlights the need to use a long and strong secret, so perhaps this system fails to do that. Several JWT cracking tools exist. I decided to use John the Ripper. The version I had installed didn't yet have JWT support, so I had to download and compile the latest version. Also, John the Ripper expects the signature part of a token to be in hexadecimal rather than in base 64, so this needed converting too. It only took a few minutes for the secret to be found using a brute force incremental strategy, essentially trying every possible combination to see if it matches. Feeding the discovered secret into the JWT decoder confirms that this is indeed the right secret, as the signature verifier turns from red to blue. Any changes made to the payload will now be signed and trusted by the application. Here I extend the expiry period out to a future date and copy the new JWT token to the clipboard. Back in the app, I use Firefox's developer tools to bring up a JavaScript console to write this value to the npauth local storage location, which the app expects to find it. A quick page refresh, and we're in. The ELF database app allows a user to query the North Pole directory. It also provides a profile page for the currently logged on user and contains a mysterious Santa panel, which is restricted to Santa Claus and his immediate family. The directory search is limited to searching for elves and reindeer, but by following the LDAP injection guide referenced by OneOS, it's possible to get a full directory listing, including the user account details for Santa and his wife. A new JWT token is generated to assume Santa's identity and written to the local storage. A quick page refresh and opening the profile page confirms that we're now logged in as Santa, but there's an additional layer of access control on the Santa panel whereby it requires Santa's password to be re-entered. This should be stored within the LDAP directory. It's just a case of tricking the system into disclosing it. I went back to burp to tamper with the LDAP query parameters, specifically that which controlled which fields are returned in the search results. I tried guessing several different options and eventually scored a success with the user password field. Based on the length of the data returned, these are probably MD5 password hashes. Hashing algorithms make it extremely time-consuming to recover an original password, but thankfully a number of rainbow tables exist online which contain pre-calculated hashes in a lookup list. This hash is computed from 001 cookie lips 001. So, along with all the other security weaknesses discovered in the North Pole systems, we can add failing to sort password hashes to that list. Feeding that password into the Santa panel section of the EDB app provides access to the letter we were tasked with discovering, a letter from the Wizard of Oz. Task 8 complete. Task 9. Which character is ultimately the villain causing the giant snowball problem? What is the villain's motive? By this stage, more than enough pages of the Great Book have been found, and completing the final level of the North Pole and Beyond game is trivial with all the tools provided by the elves from completing the terminal challenges. It turns out that it's Glinda, the Good Witch of Oz, behind all the giant snowball attacks on the North Pole. Her aim was to stir up hostilities between the elves and the Munchkins and cause war. She could then sell potions and spells to both sides for huge amounts of money. So sadly that brings an end to the 2017 holiday hack. There were certainly a few times along the way where I felt like I'd hit a dead end, but it was immensely satisfying to have those light bulb moments where everything clicks into place and the solution just crystallizes. There seemed to be a good balance in the hints and clues, providing a gentle nudge in the right direction without taking away the fun of the challenge. It was also really warming to see a broad range of players taking part and using the chat system to help others out who'd got completely stuck in a particular area. Finally, a massive thank you to Sans and CounterHack for developing and running this exercise. As I mentioned before, I don't get much of an opportunity to get quite so hands-on in my day job, so I really appreciated the opportunity to blow the cobwebs out of my system and learn a few new things along the way.